Okay, so this is going to be very important for critical thinking because we live in a world where people love to throw around numbers. Numbers have power, but numbers can hide the truth a lot, especially if people use them in the wrong way. So we want to make sure that when you leave IUSB, you know how to deal with all of these measures that we've been introducing. So we're going to take a look at issues when you're interpreting the correlation coefficient. So if somebody tells you, oh, I did this study and the correlation coefficient is 0.17, we're going to give you the skills right now to interpret that correctly, because as you'll see, there can be ways to lie with correlation coefficients that you need to keep in mind. All right, so issue number one. Issue number one, very important issue, you need to consider restriction of range. And this is especially important when you find a low correlation coefficient. So if somebody mentions that there is, they've done this study and there's a low correlation between these two variables, a little red flag should, raise in your mind, a little siren should go off, and you should say, let me see your range of your data. Why is that? All right, so let's take a look at this hypothetical data here. There's a positive correlation between funding and academic performance. That's why scholarships and financial aid exists, right? So the more funding you have, the better your academic performance. And let's say that I went out and I interviewed, 1,000 IUSB students, and I said, what's your GPA and how much funding do you get per year? And this is the data that I got. If I took this to, let's say, the governor of Indiana, and I told him, I go, look, I've done this study, and I've talked to all these IUSB students, and I've asked them how much funding do they get, and I've asked them what's their academic performance, and look, the two of them are correlated. And I think that we should do a study to see if academic funding actually causes performance, because they're correlated, so maybe there's a causal connection there, right? That's my data. Somebody else might go and talk to the exact same population of students. But if they don't get the range that I did, if on the other hand, let's say that they only talk to students that had low amounts of funding, let's say they go to one particular neighborhood where it's lower socioeconomic neighborhood, and they talk to the students, but only the ones that have lower funding. Notice that these dots here are the same students I talked to, right? It's just that the second study didn't talk to all of these students. So because of that, they have a restriction of range. Same situation, same population, should have the same result, but because there's not as much of a range, when you fit a correlation coefficient to that, it's not a strong relation. It actually goes way down to almost no relationship whatsoever. So this occasionally happens, and you will hear people argue back and forth about how, in this case, if those two people were in the same room, I would be sitting there going, well, my studies have shown that funding is highly correlated with academic performance. And they would say, well, my studies show that it's not highly correlated. And I would say, well, I talked to students here at IUSB, and they would say, well, I talked to students here at IUSB. And you can go back and forth and not understand why you're not agreeing until you remember that restriction of range and realize that, yeah, they talked to the sample, but they didn't have a large range. So they weren't able to pick up the actual truth of what's going on because of that restriction of range. So if you see that low correlation and it doesn't make sense, think about, was there a restriction of range in the data that they collected? All right, issue number two. Issue number two is the curvilinear relationship. And this is why it is always good to take a look at a graph, a scatter plot of the actual data, not just the correlation, the fitted correlation line. And this is an issue because the correlation coefficient, the Pearson correlation coefficient, only describes linear relationships. It only describes relationships that can be best fit with a straight line. So this relationship between funding and academic performance can be best fit with a straight line. That's a pretty good line to draw through these points. Sure, it misses some points at the top, it misses some points on the bottom, but in general, it's close to most of these points. That's a linear relationship. Curvilinear relationships don't work the same. So here we've seen this example before, music complexity and enjoyment. This is a curvilinear relationship because music that has low complexity typically is not enjoyed by individuals. Music that has high complexity, typically not enjoyed by individuals. Music somewhere in the middle, this is the stuff that is pop music, mainstream music, highly enjoyable music by most people. This is a perfect relationship. This is as strong a relationship as you can get. But if you reported the Pearson correlation coefficient to this, you would get a correlation of 0, indicating no effect. So if you were to only rely on the correlation coefficient, you could say that there is no relationship between music complexity and enjoyment. My Pearson correlation coefficient is 0. It's 0 because this is curvilinear, and you're trying to fit a straight line to a curved relationship. Can't do it. So if you read this, again, you have to do your critical thinking and say, look, that correlation coefficient is low. It makes sense that music complexity and enjoyment should be related somehow. Maybe this person is fitting a straight line to a curvilinear relationship, and that's why they're getting such a low correlation. All right, so those are two issues, curvilinear relationships and restriction of range that were in your textbook. This last one here, I'm going to let you know about because this actually happened to a student here at IUSB that was working on their advanced lab. So I will bring it up here as well. And this kind of ties back into Homer Simpson at the beginning. It's actually known as the Simpsons paradox. Not named after Homer Simpson, but named after another Simpson. And this is when correlations can actually reverse when groups are combined. And it is a paradox because if you, for example, look at undergrads and measure their relationship on two variables, they might have a positive relationship. If you look at graduate students and measure their relationship on the same two variables, they may have a positive relationship. You combine those two groups, surely, if it's positive for one of the groups, positive for the other group, when you combine the two groups, it should still be a positive relationship. Those relationships can reverse, and that's the Simpsons paradox. So be, again, very wary of this, and this one will actually happen at all strengths of correlations. So let's take a look at this, and I'll give you some hypothetical data where this could happen. So here we have percentage of scholarships on the x-axis, and here we have the grade level for individuals, and we'll code the grades as just continuing numerically. So, if you go to the final grade in high school, you're in grade 12, and then your first year here, let's call it grade 13, your second year here, grade 14, just so we can have them on that interval scale. Actually, I guess that would be a ratio scale because we got that absolute 0. Anyways, if you took a look at different scholarship opportunities, you'll notice that they tend to increase as grade level increases, right? So it's very important to make sure that students in high school can actually still afford to go to high school. So there will be more percentage of students, and this is hypothetical data, but in general, there will be higher percentage of students getting scholarships in grade 9 than there are students getting scholarships in grade 5, than there are students getting scholarships in grade 1, some sort of financial aid. So this is a positive relation. Look how positive. It's 0.99. It's about as high as you can get. Positive relationship between grade level and scholarships. As grade level increases, so too does the percent of scholarships. That's group number 1. Group number 2 is adults. So we had children in elementary school, and now we have adults going through to university, master's, PhD programs. And this is also very typical, that the amount of scholarships that you get in your undergraduate university is less than you will get in a master's program. So when you're applying for master's programs, take a look at their scholarship opportunities. There are more than you will have access to right now. And the same goes for PhDs. PhDs have higher levels of scholarships than masters. Masters is higher than undergrad. And again, if you fit the correlation to this relationship between grade level and scholarships, we get, once again, a extremely high correlation. So we got high correlation for children, high correlation for adults, positive correlation for children, positive correlation for adults. And if you took this data and said, well, let's just combine all of this into one big data set and calculate the correlation coefficient, high for children, high for adults, calculate the combined correlation coefficient, you get a negative correlation. Negative when you combine two highly positive correlations, and that's the Simpson's paradox. And what's happening here is that when you take a look at the graph of them, in each group, the correlation is positive. But because it drops from elementary school to university levels, because the amount of scholarships drop between those two, the overall pattern is actually negative. So within groups, highly positive correlation. Overall pattern, highly negative correlation, and that is the Simpson's paradox. And again, the student that was here working on their advanced lab did not know what was going on because when she looked at the individual groups, high correlation. When she aggregated all her data, where did her correlation go? She was a victim of the Simpson's paradox. And actually, that's when I first learned about it as well. All right, any questions about correlations? Okay.